Hello, Tom from Every Step Physics, EveryStepCalculus.com. The physics problem, as you can see, regarding an International Space Station, how much time or the period that it takes to go around the Earth. Let's do it. Physics, to get to my main menu, I'm already at planets. You scroll down to planets. And we're going to scroll down here because we want to find the period. Here's period of orbit. As you can see, I'm giving free advertising to these people here, Quaker Oats and Walmart and whatever comes up on the screen here. I tell you a little bit about Kepler. Kepler's in charge of the periods here. His third law, which is t squared divided by a cubed equals k. And this is the radius of the planets, and in astronomical units. And when you use algebra, k is always 1 on the Earth here. Around Earth works out to be 1. Actually, in my menu, I do have how they get that, or how they compute that, which you can choose in my menu for Kepler's constant. And but anyway, just a little bit of information. I'm not really thrilled about teaching in this stuff because all I do is want to show you how to do problems quickly so you can pass your test or do your homework quick and move on to some stuff that's maybe more important for your major. So anyways, t is the period and a is the object's orbit radius in astronomical units. AU, Earth equals 1 AU. So that's the reason it's 1. So but anyways, I ask you if there's AU again. If there would be in the problem here, we'll give you AU units or whatever, and then you would say yes to this. We're saying no because there's no AU given, but there is height or altitude given. Well, not really height or altitude, but you can see that it's above the Earth's surface. So I could put in here as height or altitude or above given, you know, but you have to think a little bit and work with me a little bit. Let's say yes, there is, okay. And so now we're going to enter the height. And we're going to press alpha first before you enter anything in these entry lines here. And the problem says alpha 4, 0, 0. Always put down exactly what they tell you here because I do the conversions for you. Press enter. It's in kilometers, number 3. You can scroll to it or press the number in front of the menu item. And of course, this kilometers, you're multiplying by 1,000 to get meters, okay? We're going to enter the mass of the planet. Now, you have to memorize this. And I just know it because I've done this so much, but as I press alpha 5.98 times e to the 24 kilograms. Enter the radius. Radius of the Earth is alpha 6.37 times e to the 6 meters. Excuse me. I always show you what you've entered. So in case you made a mistake, you can change it. I say it's okay. And we have to add the height above the Earth to the radius of the Earth because everything's computed from the center of any planet. I give you the gravitational constant, which is Newton's invention, 6.67 e to the minus 11. And we do our calculations. Here's the formula, 2 pi times the square root of r cubed divided by gm. G is the gravitational constant. M is the sum of the masses, but the small mass doesn't make any difference because the large mass is so large that it when you add them together, it doesn't make any difference. It's the same as the large mass. And this would never be the orbiting body, but the planet that the body is orbiting around, like the sun or Earth or Jupiter or whatever. There's other kinds of problems involved too, you know. And so then we put in the variables. 2 pi times the square root of here's the radius that we computed, the adding of the 400 to the 6.37 e to the 6 meters, and then here's the gravitational constant and the mass of the Earth. Okay, 2 pi times the square root of 3.1 e to the 20, which is this cube, 6.77 e to the 6 cubed, and then multiplying these two together, the gravitational constant and the mass of the Earth, and we come up with the square root of this. We take the square root of that, we come up with 8.82 times e to the 2, which is 882, times 2 pi equals 5.5418 e to the 3 seconds. Everything's in seconds when you're working with time and in physics. Remember that, okay? And then I convert it to whatever they might ask for and whatever is convenient. For instance, in minutes it's 9.2 times e to the 1. Well, that's 92 minutes that the International Space Station goes around the Earth. Every 92 minutes it goes around. And years is 1.5 hours, etc. So whatever they might ask in the problem, that's what you would put down. But you could put down hours or minutes, you'd get the problem correct. So go to my site, buy my programs. They're only $30. Yeah, I have over 370 of them that go into your calculator, and will solve all kinds of problems for bullets and arrows and whatever have they, accidents, a million other problems, okay? Show you step by step how to do it. And remember that classes are scored on partial credit in the class curve, so whatever you put down on your paper, you're going to get some points for it. And you're not competing with the actual problems in the thing, you're competing to the person who's sitting next to you. And if you can get 5 or 6 more problems correct on a test than he does, you're going to get an A, and they're not going to get an A. So that's the system. So anyways, go to my site, buy my programs. They're well worth it. Extremely cheap for the years that I put into this stuff and programmed this stuff. And I'll help you too if you need help with physics, okay? All right. Hey, have a good one.